Are you looking for a reliable way to auto-eject prints, even with a smooth or not self-releasing build plate? This video is just for you. How this automation technique works is first the printer will print its object as usual, and then once the print has finished, it'll wait for the bed to cool and the arm is extended downwards. Then this arm reaches beneath the print bed and it grabs on and lifts upwards. As this print head moves upwards and the arm is pulling the bed up, it flexes the print bed. This causes the prints to eject. You can see here my print fell off with very little flexing. That's because I used a self-releasing build plate. But because we're able to flex the bed, you can actually use all sorts of different flexible build plates. So like a smooth build plate or those cool holographic build plates, those work awesome with this automation technique. And then at the end of the print, we move that arm out of the way so it doesn't get caught on the next print. Then the printer will move across the bed just in case the print didn't slide off. So that way the bed is nice and clear for our next print. There's already ways to automate your printer out there, but what sets this specific technique apart is that you are able to do everything with only 3D printed parts. So you don't need to purchase a kit that comes in the mail. You don't need multiple build plates, just one build plate works. It also works really well for beds that don't self-release. As long as the bed can flex, your parts will come off reliably and well. So some of the prints I do, I like to use those like holographic build plates that leave like the cool design on your bottom, on the bottom of your print. Or like the carbon fiber texture build plates. Those work awesome for this technique of automation. In the description, you'll find a link for where you can find these files. Once you get the files, you'll be given a zip folder. In this zip folder, there are 4 different items that you'll need to automate your printer. So this one here, this is the 3MF file for the lift kit, and then the other one is for the bed clamps. This is the profile that has the G code. So you just download this, and in Bambu Studio, you'll be able to just select that profile and it'll do the correct NG code. And then this is like a test G code, which we'll run that after we assemble our kit. So first, I'm going to download and open the lift kit file. So you can see everything here is ready to go. I already have the support settings already, so all you have to do is slice and print. And for this print, you can do any material. PLA works great. After printing the lift kit, we want to print the clamps to hold the build plate in place. This gets a little tricky though, because the bed on your printer heats up. So if we use a material that becomes flexible when it's heated up, it's not going to work. So you cannot use PLA to print the bed clamps. Depending on what type of material you usually print, some materials will work and some won't. So if you are only printing PLA, you can use PETG to print the bed clamps. But if you're printing with PETG, you need a hotter bed temperature. So PETG clamps will not work for PETG prints. So I'm going to walk you through how you can decide if a material will work for the clamps or not. and it all has to do with the heat deflection temperature of the plastic. Heat deflection temperature is a temperature at which the plastic will become, basically at which it can become flexible. So if your bed is hotter than the heat deflection temperature of the plastic used to make your clamps, then you're gonna have problems. So here on Bambu Lab's website, I'm looking at their PETG material. And pretty much anywhere you can buy filament, you can find information on that filament. So if we scroll down here, we see a lot of technical data. So I'm looking for heat deflection temperature, so HDF right here. And that shows the temperature at which this plastic will deflect. So as long as my bed stays below that temperature, I can use PETG. I plan to use hotter temps, so I actually used ASA plastic for my bed clamps, and that worked awesome. Unfortunately, to print with ASA, the Bambu A1 Mini print bed does not get hot enough. So I basically just modified the ASA like material profile to use a lower temp for the build plate temperature. And then I just used a ton of glue stick on the bed, and I was able to get this printed off on my A1 Mini in ASA material. And now I'm able to use pretty much any material I want when printing with my A1 Mini. The first thing I do once I've printed my parts and taken them off the build plate is I like to remove the support material. On this little piece here, there's support inside and you have to dig it out. I find these little wire cutters work really well. And then once you have all the support off, you're gonna grab the long arm, that's what grabs the build plate, and slide that inside the sleeve. Pay attention to which direction that the arm is. And then you're going to add this little clip to the top, and it should be a snap fit, but if it feels loose, add some glue or tape or something to hold that better. And then you will need a spring from a pen or pencil. You only need one. I'm doing two for this example so you can see different sizes. So you put that little stopper inside, and then a spring, and then we have different sizes of like caps for the springs. So choose a cap that will add enough tension to hold the arm in place, but it still is able to slide relatively easy. So for this example on the long spring, I'm using the largest cap, and I'm sliding this back and forth, and it feels pretty loose. It feels like the arm might be able to slide out. So I try a shorter cap, and this one seems to be a lot better. When I slide it back and forth, it's still able to slide, but when it is in place, it's nice and snug. Next, I'm going to glue the cap with the spring inside. I printed this piece here with a brim. Unfortunately, the brim stuck a little too well, so I had to use these wire cutters to remove all of that brim. And then next, we're going to move on to actually placing the parts on our printer head. So remove the cover, and then remove this screw, and then these two screws up here on top. Next, grab the whole sleeve arm assembly and that'll fit right on top of the print head. And you're going to replace those same 3 screws that you just removed. Now that the arm is assembled, I like to double check it's sliding as it should. Now we're going to move on to adding the hook on the top of the Z-axis. So this is how we're going to move the grabber arm up and down. So start by just removing the old cover. And next we're going to put the hook on the top and use those same screws that was holding the cover on to hold this hook in place. We don't want this wire to get caught on the hook while we're printing, so we are going to actually run the wire on the back of the printer. So we're going to remove the spool holder. If you've been using an AMS, you probably have not been using this, so you can skip this step. But once this is removed, we're going to take this back cover off. Now that we've removed that cover, we're going to replace it with our wire holder. So this piece is going to hold that cable on the back side of our printer. If you have been relying on that spool holder on the back of your printer, you can easily 3D print a spool holder that just sits to the side of your printer. Next, move the print head all the way to the far side of the x-axis, and then we're going to place the cable back here and clip it in place. And then I like to move the print head back and forth to make sure it can freely move with no issues. Next, we're going to add the bed clip clamps. So turn the printer on its side and then remove the front 2 screws on the print bed. Now we're going to replace those 2 screws we just removed with the clamp bracket in place. So the other parts that were gray, I printed in PLA, and that works great. For this bed clamp bracket and the clamps themselves, PLA does not work. PETG works good if you're only printing in PLA, but I did this in ASA, so I can print with PLA and PETG. And then the clamps just slide in place onto the bracket. And I like to double check that the bed can freely lift without sliding off. Next, I'm just going to move the Bowden tube onto my external spool holder. Again, if you're using an AMS, you don't really have to do this step. And then I uploaded the test code onto my SD card and ready to turn on my printer and run that code. So this test code is what your printer will do after the end of each print when you automate your printer. So the first thing it does once it finishes a print is it moves to the top right, and it's going to use that hook we place up there to slide the arm downwards. Now that the hook has been lowered, the hook is below the nozzle. So when the print head moves down and the bed slides back a little, it's able to scoop onto our flexible build plate. And then the print head will move upwards to flex the build plate. And this is just a test, but usually you'd have your print on the bed and this flexing motion will pop the print off of the build plate. After that, the print head moves downwards to set the bed back down, and then we have to lift the hook back up so it's out of the way for the next print. The last thing we need to do is load in our user preset. So go up top and click import, and then import configuration, and then locate where that zip folder is. And within it, you'll see this file, and you can open it up, and that will bring in the user preset. So now in Bambu Studio, you should be able to click this A1 Mini bed lift profile. So you can see here we have a few modifications from a regular profile. The first is we have this small exclusion area. So the nature of this bed lift automation is the nozzle comes to that back right corner, so we're not able to place things there. And then the next thing is we've modified the start and finish G code. So in the start G code, the only thing I modified is I turned off the vibration. I found it pretty annoying for the printer to be vibrating at like 3 a.m. in the morning. So I just commented all of these out. So you see these semicolons, if you remove those, you can bring the vibration back in if for whatever reason you wanted your printer to do the vibration compensation every single print. And then for the NG code, this is a little bit different than the typical NG code. First, I added this area for the, basically the printer waits for the bed to cool down. And you can input different temperatures by changing that S20. So you could do like S30 or something if you wanted it to spend less time cooling. And then here I have like the actual machine movements of lowering the arm, lifting the bed, and raising the arm back up. So yeah, other than that, everything is the same from the original G code. So now we can open up a file. So I'm going to open up a Benchy model. And when it comes to using this bed lift technique, it works super awesome on larger prints. On smaller prints, sometimes it doesn't do as good. So like this Benchy here, it would probably work because it's big enough. But one thing we can do to make it work better is to change the orientation. Now more of it will be affected by the bed flexing. So yeah, I can go ahead and slice the plate. And then from here, I could just hit print and it would do a single print and remove the print at the end of it. I actually like to do that for a lot of things, just so, you know, I can print something away from home and then print a different thing. But if you want to do multiple things in a row, go to File, Export, and export the G code. So I'm just going to name this like Benchy, and then go to that file and open it with a text editor, not Microsoft Word, something like Notepad works great. And select all of the G code and copy it. And then now I'm going to paste the entire G code multiple times. So it doesn't look like it's moving, but I'm actually hitting like paste. I pasted 4 times. So this will actually print 5 Benchies. And then I save this. And it's important here, you want to hit .g code at the end of this file. Save it as a .g code. and save that onto the micro SD card and put that in the printer, and now you are ready to go.